Well, first of all, thank you for playing models to the organizers or the organizers, no, to invite me to come to Pittsburgh for first time. And today I'm going to explain my last 7 years doing digital fabrication, not just in the Europe and the US, also in Mexico. So today I'm going to present humanizing technology, crafting tradition through innovation. So first, the machine-centered projects. So I studied my MIS in the ETH, and I did projects with different materials like plastic, metals, recycled materials, air, textiles. So I'm not going to explain all the projects, so I'm just going to talk about which materials we work and why. So the first one is plastic. So we did a lot of different experiments with plastic. Plastic for me is one of the most easiest material because it gets ready in 24 hours, it gets dry, so you can play with a lot of textures and geometries. So for example, first of all, in the Robotic Atelier 2029, in the Norman Foster Foundation, we work with recycled plastic from the oceans. So in this case, we did these little elements from facades, and Foster said for sustainability, we not only have to be careful about the material, also with the size and the replication of this material to be these elements able to be installed easy in the construction. So in this case, we just work with these geometries that you can be able to assemble in all directions. No? So you can see also these elements can be replicated easily. And actually, one of the biggest challenge we was is the thermal insulation. So we create this also empty space in between because we want to create, if you have a very hot weather, you can just leave it like that and it plays like an air camera. But if you have a very cold weather, you can put insulation material inside. Then we also, in the MIS, we did this pavilion called Digital Bamboo Pavilion. And in this case, we work also with plastic, but with fabrics. So this pavilion, it was built with 3 construction systems, like the bamboo, then the nodes, and then the fabric. I was in the fabric team. So also you can see and realize 3D printing plays not only aesthetic play, an aesthetic role. It's also working as a structural, if you need a more structural part, you can add more levels of printing, and if you only need to draw something in the panel, you only can print a very thin level of 3D printing. So also the other part, it was the nodes. The nodes was a very easy system because we were students and we were not able to get builders in the site, so we just do these connections and we just use the nylon, these nylon nodes. And then with 3 zip ties, you already can connect a lot of bamboo structures. So at the end, this is the final result. And thanks to technology and computational design, we can also be able to mix natural systems like bamboo, but then with digital fabrication and textiles and other combined construction systems. So this is the view and the perspective you have when you are down of the pavilion, and then you can see the 3 systems working together. So the last goal of this pavilion is just to be able to build with natural materials and what is the most challenge in terms of structural strength. So the second material that we work is concrete. So we work in collaboration with Dr. Anna Anton, and in this case, we work with concrete calligraphy. We did a lot of facades for housing, and this is mine, the 4th one. And we were just also trying to understand the concrete, because the concrete is not the same printing with plastic. Concrete is a liquid material, so you cannot stop the printing. So in this case, we have to design a continuous line, and then you have to do a continuous 3D printing. And also the aesthetics is totally different. It's more rustic. You can do less detail, less texture, so we can be able to design with the material. So in this case, what we do these facades that they connect in the nose, and then they just replicate it. And after this is a perspective of the facade concrete, and then we select just one of these modules just to build it 1-in-1 scale. So this is the final result, and after this also we can see that we can use the extrusion of the faces also for a table, a bookshelf. So also these kind of facades also connect the interior and the exterior of the building. Earth. Well, first of all, with earth is absolutely totally different. For me, it's one of the most complex materials for 3D printing because earth is directly connected with the location when you are. So all the composites of the earth change depending on the location you are. In this case, we also take advantages of the machine. So this machine, we use the pressure of the machine just to knead all the nodes. So this is the first design that we did from a fair in Brazil, but this project was did in 2020. So it was in COVID, so the Brazil festival was canceled. So at the end, we were working with air from Switzerland. That was the worst. Because why? The weather is super extreme, so the earth is not really good for construction. So in this case, what we was finding is this. But this is not like an error. This is something that the material is expressing to you that the quantity of aggregates you are adding are not the correct ones. So what we did, we studied different combinations of materiality and also depending of the sand, rock, clay, and water percentage that we have in different mixes. At the end, we just select the most optimized mix, and after this, we also think about the second complexity, that is the machine. The machines have a limited working space, so you cannot just work whatever you want. So in this case, we have also to think about if I'm going to just move the working area or the machine. In this case, we just move the machine, and this is on this is one of the able space that I was able to work with the machine, and then I have to move it. So after this project was taken by 2 PhD doctors nowadays, and from the Gramazio Color Research called Clay Rotunda, and this is the final result that we built in this project. And actually, you can see how these parts are needed. You can see these lines, and this means the robot were moving through the whole wall. Then the final material that I print is mineral foam with Patrick Bedorf. In this case, why? Because in terms of sustainability, we need to rethink about the methodology we are working with, and also the materials we should be more responsible with the environment. So first of all, in this case or this project, I put the lattices that in Mexico are super common because we have a weather that allows us to have a microclimate in between the outside and the inside of the building. But now this is an image that I really like because they are from a social house in Mexico. And then you can see one of the elements that is the concrete block performs that everything, that the support of the bed, the wall, the window, everything. So detail fabrication now allows us not to just base it in existing materials. Now we can also change the vocation of these elements, and then we can just adapt it depending on the necessities that we need. So first of all, I classify this thesis in 3 groups. First, the design, then the material, and after this, the fabrication. Talking about the fabrication, I just print in 10 minutes, then I get dry in 48 minutes, and after this, I just put it in the oven for 48 hours. So in total, for just doing 1 brick, I just need 5 days almost. So this is how it looks like the material before the firing, and then you can see this is a foam because you can see the bubbles and everything. And after the firing, the material looks like clay. But one of the biggest advantages is the density. The density of this material is very low, so it's replaced the clay, and it is more sustainable because it's made by recycling fly waste. So this is the methodology or the tools that I use. This is a robotic arm, a material extruder, and the printing bed. And for first time, the extruder, it was not moving. Always the extruder is moving with the robot, and in this case, we moved the printing bed because the material was super low density, so we cannot be able to move it very fast. So I did this geometry matrix just to see, okay, this is the very basic geometries, just to understand which geometry are the most stable and optimized for this materiality. And then I did a lot of printing. So you can see from the beginning, I print the whole block and then just the perimeter. Then I did this strategy squares in the infill, and after this, the circles. So first of all, my first objective is how can I get the best quality of printing? So after this, I have to move this matrix, the layer height, the layer width, the robot speed, the foot rate, just to get the best printing quality. Then I found this. What does this mean? So this is a section of the material after printing, and then you can see the first 3 layers are super squeezed, and after this, the other layers are expanded because this is a foam. So we need to start to design the things taking in consideration how the material behaves. So the second objective was the height. How can I get a better height? So if I don't use an infill inside the printing, I cannot get more than 10 centimeters. So after this, I did like 4 strategies just to get more height, and at the end to understand what is the most stable. So after this and at the final, we just compare all the physical properties of between all the 4 geometries, the weight, the volume of material, the time of printing, and then the density. So you can see like the final printing used a lot of materiality and also a lot of printing time, almost 15 minutes. This is not optimized. But then you can see the first 2, they use maybe the quarter of the volume of material, and then they have a more less time of printing. So at the end, the circles were the most stable geometry to print with this materiality. And after this, what are going to be the applications? So when I print in these bricks, I realized 2 things. If I don't flip it, I can do a wall application. But if I flip it, I can do a screen application. So I studied first the wall. So this is the wall, about 2 meters, 1 meter, and I need more than 200 bricks. And if I say before, like, I need 5 days just to get 1 brick. Imagine 200 bricks is a lot, no? But this is a perspective how this wall looks like in an architectural space. The second application is the screen. Then with the screen of almost 2.5 meters and 1 meter, I only need 24 bricks. So this is more optimized, so that's why I select to do this panel, no? And one of the wonderful things is the density of this material is so low, so all the whole panel with the screen, with the concrete, and also like the frame, only weighs 15 kilograms. So this is very lightweight, and then you can also carry it by hand. And this is some perspective. I also recreate the microclimate between the inside and the outside of the building. And also with computational design, you can also scale these circles and try to get whatever you want. If you want to close the screen or open the screen, you can be able to do it. So at the end, we are always like getting all the natural light and ventilation. But I not only do like projects with robots, I also work with my hands, so this is a more human-centered projects. So I work in Ensemble Studio in 2019. We did like the furniture for Domo Canvas, that this is big pavilion made with concrete and earth. And in this case, they want to have like a furniture that will be matched with this kind of aesthetics. So in this case, we use this fabric that is a concrete fabric used by the for roads, and like it was very, very hard. So I knit it by hand, like Hermes bags, you know, like Louis Vuitton. So I really knit it by hand. And after this, we just add some water, and then with your hands, you will be able to create these wrinkles. So after this, I did 2 outputs with digital fabrication. The first one was a CNC milling, and the second one was 3D printing. And I love this image because everybody tells me, you did first the 3D modeling, and after this, you did the furniture. And it's not true. I did it first with my hands, and thanks to technology and 3D scanning, I could be able to get digital fabrication outputs. So I was thinking, what happens if you have like an analog design made by hand, and then you can scan it, and then you can get a digital fabrication output? What happens if you do in the opposite side? So is this possible or not? And that's how I found that in Mexico, Manufactura, that is my practice, no? I moved to Mexico in 2022. Well, the main slogan is innovation based on tradition. Why? Because I don't think and I don't believe like machines should replace humans or should replace our tradition, because our traditions are more ancestral and also are more, have more impact in our society. So we respond. One of the main goals and problems on construction in Mexico, that the first one, and this is very global, we are very responsible of the 40% of the CO2 footprint. The second one is the fair labor conditions. These are real pictures of the builders in Mexico. Every 75 seconds, an accident occurs in the construction industry, making it the first job with the highest risk and mortality in our country. This means there is a lot of risk building things, no? So we want to redesign the way of making. We believe in the conscious use of technology for a sustainable built environment. Well, this is our workshop. We are based in Colonia Doctores. Colonia Doctores is a like old factory neighborhood. It's also very interesting. This is the factory we are based at. This is, well, the factory is like a very old textile factory, and it is also very interesting because we are a factory inside a factory. So we have like a robotic arm just to help us to innovate and to create digital fabrication. So what is our services? We have material developing. We also have research projects with a lot of academia in all levels. We have commercial projects and education. We always have workshops every end of the month just to also be able to impact other communities that they are not able to go to school. So what of our technology? We have 3D printing, that is the most common. And also we automate other kind of things, for example, knitting. So what's our material? This is the waste classification in Mexico, in the country. So more than the 63% of the waste are organic waste that they came from the food industry. Then paper and cardboard, glass, plastics, metals, and others. That's why we classify our materials in two groups. The local materials, which represent the tradition, like clay, air, ceramics, or talavera, and then the circular materials that these ones are made with recycled food waste, like, for example, eggshell, wood, paper, fibers, and others. So how we work? We just first develop the material for 3D printing, then we have a geometrical prototyping, and after this, we create a mass production for depending the application. So our materiality mostly are waste. Nobody wanted, it's garbage. So in this case, we just recover it, we sanitize it, and we convert it in professional projects like bricks, lattices, or even roof, and then these materials can be applied like in different applications in architectural scale. So I'm going to explain like 4 projects that we did in the last 4 years. The first project was the actual project. We did it in collaboration with Montserrat Ayala. In this case, the principal question was, it is possible to build with our waste? The answer is yes. Why egg and not other kind of shells? First of all, because the egg is, Mexico is the 4th consumer of egg and the 5th producer of eggshell. So we have a lot of volume of eggshell very, very present in our diet. So how we work, we just get the eggshell, we sanitize it, and then we transform it to be able to be 3D printed. We got the eggshell, we just sanitize it, we also convert it in a very little binder. After this, we combine it with other organic binders, and then we got the bioceramic that be able to be 3D printing in our robotic arm and our industrial extruder. So this is how the material goes, meanwhile the 3D printing, and you can also see like there is a little pieces of the eggshell there. So it is totally possible to build with our waste. This is how material looks like before it gets dries, and after it gets dries, it gets the final color. So we also do a lot of like geometrical tests about which of the geometry are more optimized. In this case, this one is more optimized for this material. And after this, we did 2 applications. The first one was a little wall of 1 meter and 1 meter, just to know what is building with eggshell, what it means. So this is the first application, and actually, thanks to the assemble system, we don't use any steel bars, any nothing, just the walls and just the bricks, and then we can get a very more stable wall. So this is the final texture, So this is very beautiful also because I don't want to add anything else. This is absolutely okay. And then this is the final results of the bricks. This is the first prototype, and the second one was a little column, but the final results are not the most important. This is the most important. So the second application, what we did is, what happened if we change the shape? It will be able or not? So we changed it from circles, and then we did 30 different circles that they connected by their parametric infill. So at the end, we just put it one on the top of other, and then we just built the final geometry. Currently, we are working with the Instituto Politécnico Nacional, that is a public university in Mexico, just to create and certificate this material for construction and get to the other level. The second project is Sueños with Air and Concrete with MIT, Italy, and New Story. So MIT, the digital structure school, told me we want to do like a pavilion that can be also interesting, but related with social housing in Mexico. So this is the most common materials for social housing, that is concrete, air, and clay. This is the pavilion. So the pavilion was built with 2 walls of compressed air block, And then Vigueta and Bovedilla, that is a really Spanish system of construction for the roof and very common for social housing in Mexico. So in this case, what happened and what is the change? The Vigueta and Bovedilla, the Vigueta, it was thinner and then they get thicker and then it started to be thinner. So all the Bovedillas change. So that's why we have 18 Bovedillas totally different and they adapt through the geometry. And after this, we just mirror the 18 Bovedillas. So 3D printing is good for that. When you want to change and want to adapt to different geometries, then it's much better to use 3D printing instead of molds. So again, we use our robotic 3D printing, and our material, we did like a collaboration with Amphora, that is like a very oldest ceramic company in Mexico, and we create a mix of two national clays. Oaxaca clay, that is from the south, and it gives the color and the texture, and then Zacatecas clay, that is from the north, and have a lot of sand that really get a really good compression strength. At the end, this is how the Bovedillas look like before, the firing session, and after the firing, they got the terracotta color. That is very common in Mexico. So also you can see how the Bovedillas work with the Vigueta, They have this like slab here, and then the Bovedillas can put there. This is the 18 different Bovedillas, and the geometry are the protagonists of this project. So at the end, we just fabricated 220 Bovedillas of this, and after this, we just built it by hand in the construction site. It was in the downtown. So this is the final result. It was also part of the PhD from Sandy Court, from MIT. And then this is the final result. And this festival happens on September. And September is the earthquake month in Mexico City. So it shakes 2 times and didn't happen there. So anything broke there. So this is the final result. Then in 2023, we just collaborate with La Metropolitana. This is like a furniture designers. And they asked me, we have like more than half a ton of waste of sawdust in our factory every day. So we just combine it with the same binder from the eggshell, but instead of using the eggshell, we just use the sawdust. This is the sawdust of salam. Salam is like a sawdust from the south of Mexico, and then we just combine it, again with natural binders, and then it was again possible to build with the waste, This is how the material looks like after the drying session, and then we put it also in the sun. In difference with ceramics, these kind of mortars do not need a firing session. They don't need it. They just get dry, and that's all. So at the end, this is the final result, and we did 3 lattices with them. So the 3 problems that we are taking in consideration is the threat of automation of job replacement. Like the craftsmen in Mexico are disappearing. Why? Because they have a very unfair situation. They are getting older, they have a really low salary, and also they are not women. They are not diversity or equity. So we believe in humanized technology instead that the machines try to automate us. What happens if humans try to humanize machines? So we want to create a collaboration in between the humans and machines. So we did a collaboration with Uriarte Talavera. Uriarte Talavera is based in Puebla. La Talavera is not the same like ceramics. It's kind of part of ceramics, but this is a very different technique, and it's also part of our cultural heritage. It's a protected material because it came from the Spanish conquest. After the Spanish conquest, the Spanish came with this methodology to do ceramics, and then I also interviewed the craftsmen about what are your main problems nowadays with producing Talavera, and they told me 2 things. The first one is the quantity of waste they have, because it's a certificate material, and if the products do not pass the quality control, they cannot sell it. So they have tons and tons of waste like that. And the second problem is the innovation. They do not have any classes because they don't go to any educational institute. They learn generation by generation, voice by voice. So they just design things intuitively. They do not realize if they are designing or not. So what we do is try to see, okay, I cannot be able to introduce 3D printing in the methodology because it's an intangible cultural heritage, but maybe I can help in the design stage. So we just create these 3D printing products, and then we just, by hand, we just remove, like the texture, because after this, we just give to a craftsman this kind of like items, and then the craftsman reproduce it very fast by hand with his tools. So he did the molds, and then he just 3D modeled again. But in this case, he's using this kind of clay. This clay is a mixing between black clay and white clay, because the black clay represents the indigenous people and the white clay represents the Europeans. So it's also part of our, part of the history. And after this, this clay get fired, see, they get this terracotta color. Then this craftsman removed totally by hand all the imperfections, and after this, the glazing. So the glazing is one of the most common techniques in Talavera because it shines and is really represented. And after this, another craftsman will remove all the imperfections again by hand, and then the final stage is the painting. The painting for me is one of the most romantic stage, because in this case, the pencil cannot be like whatever pencil. This pencil is made by donkey hair. So this is very important because this is how the Spanish teach us how to do ceramics. So after a very industrial and a cold and a very perfectionist methodology that is 3D printing, we also collaborate with a very intuitive and very human process that is working by hand. So this is the final piece that we did. We did this column that represents the innovation because it's made by a piece made by 3D printing. And then we just put this big carpet full of all the waste, just to reimagine that we can also use the Talavera waste without, we don't need the certification anymore. So this is the final pieces, and also everything are made by hand. The people that told me that humans are not efficient, you don't know to work with humans. You really need to work with craftsmen. So this is also, we exhibit in La Casa Uriarte, that is also a very protected part. And this is one of the most largest, for me, projects, because we took 6 months, because we respect all the stage chefs to do in Talavera, but actually was one of the most wonderful projects, because first of my time, I collaborate with a craftsman. So this year, we did a residency in WASP, in Massa Lombarda, in Italia, acá con mis amigas. So we did this project called Concrete. So the question is, it is possible that we will be able to rescue construction techniques from our ancestors. The pyramids in Mexico are not just made by adobe, as everybody said. They are adobe inside, but then these adobe are covered by rocks, volcanic rocks, and limestone mortar. So I asked to the archaeologists, what is this? And they told me, this is limestone mortar that is the ancestor of the concrete. So we were actually, when the Spanish came, they are still using it for doing their big mansions or big houses called haciendas. We can see here in this image all the construction section. You can see they are using the rocks, then the limestone mortar, and then a final finish called chucum in Maya. So then the second question is, what is the most abundant type of waste in Mexico? As I already said, is the food waste. It's more than the 64% of our waste. So we get the first waste wasted in Mexico is corn. Why? Because we love tacos. We always are eating tacos everywhere, and it's part of our diet. So in this project, I collaborate with Jorge Armando. He's a chef in Berlin, and he's also doing tortillas in Berlin. He's doing the whole process of nixtamalization, and he gave me the nejayote, that is the core waste. So we also work with a robotic arm and a continuous flowing system from WASP. And in this case, we use these tools just to be able to build something bigger. So this is the nejayote, how it looks like. We just trashing it, or how to say this, I don't know, but we just pushing it by hand. We just demolish it, and then we combine it again. In this case, we combine it with yocalche. Yocalche is an Italian product made by limestone and then marble from Carrara. So also this is very interesting and beautiful, because we are combining the resources from Italy and the resources from Mexico. So this is the final result. We did 3 walls with different sizes, because we want to also be able, if it's possible, to print with these tools different scales. This is a wall of 40 centimeters, this is 60, and this is 80 centimeters. So you can be able to wall all the things to be flexible to whatever space you want to do with this materiality, So after this, we use the tortilla waste, the limestone, and in this project, the conclusion is this is a piece of Mexico in Italy. And we always want to create this circular economic system. Sometimes we just get the food, we just eat it in a house, and then we just trash it. We don't want to recover it, and we just want to transform it to construction systems. So at the end, manufactura is this. It's the conversation we always have with our machine. We connect it directly with the materials because we fabricate it, no, inside. And thanks to digital fabrication, I am able to transform it to other kind of construction outputs, no? Also, we have the opportunity to have workshops. This is an indigenous guy from Michoacán, Apurepecha. And he told me, as an indigenous, I don't have access to technology. Why? Why always technology are on the cities? So all our tools are made in Mexico, only the extruders are not, no? It's 3D Potter and Wasp. But we are also trying to get like the mix between Mexican manufacturing. Not everything is digital. Also, we have a post-production after the printing process, so most of the things are made by hand. And then during the first quarter of 2024, the construction sector was made by 8 million people, but 96 are men and just 3% are women. So the people watching a girl like leading like a project with manufacturing, for them is a new narrative in terms of equity and opportunity. So teaching, I'm the first professor teaching robotics in Mexico in the architectural school. We also use cobots just to do like little exercises to help the students to understand the communication with machines. We also use like 3D printing, very basic things to do like different geometries, using different and sustainable materialities. Also, in this case, we were always changing the materiality. I work with ceramics and then with 3D printed. I work with beeswax, and then we just also do the comparison between doing it by hand and doing it by robot, which of both technologies are more complex or not. So we also did the same with plastic. First of all, we generate these little bags by plastic, and after this, we just 3D printed just to understand the relationship with the material, no? And we also use 3D scanning, not 3D printing, for also have another kind of geometries that we are not able to do by hand. And also, we just needed these agave fibers, no, to have different outputs and facades. So the most recent project is this one. We did this furniture with Tecnológico de Monterrey. We used just a very normal Ender 3D printing that is like nothing super cheap. And then you have silicon molds. We fabricated these silicon molds, and after this, we just cast it by concrete to get these beautiful objects that you can be able to replicate it and to do different outputs like geometry, like furniture. So for finishing this talk, this is a diagram that I did in the master's degree. Data fabrication is not a linear process. It's an infinite loop between design, fabrication, but the most important, material. So that's the question. What's going to happen when people are no longer part of the construction? Data fabrication have a lot of advantages, as you already see, new applications, new materials, new optimization, but also have a lot of disadvantages. Replacing a loss of employment, loss of human touch, changing labor relationship, and the most important, it makes visible the inequality in our society. So this is a poll from the New Yorker say, can 3D printing help to solve housing crisis? This is a very different idea. Also, like Icon is believing, a new story is believing that 3D printing can solve housing crisis. But if we saw this story in the Ford Sim, Henry Ford said, if you do the same car different times, then all the cars are going to be cheaper. But in housing, it didn't work. It's not the same story. I was just landing in Washington, and I saw in the perspective a lot of house. In US, yes, you have the same house every time, but in Mexico, it didn't work. Mexico, and in Latin America, mostly of the reality of housing is this. This is the real industrial housing in Latin America. More than the 60% of the population live in self-building houses. Why? Because they don't have access to a credit. No, they don't have formal jobs, so they cannot be able to get industrial houses. Well, and also, in the Mexican housing deficit, more of the housing deficits are because the material, then the spaces, and then the services. So more than 8 million homes in Mexico are living in this condition, and they are not resilient. This is a video that it's from Acapulco, and then you can see this house is made by concrete with a concrete foundation, and then, boom, it collapsed. Why? Because we are not making construction systems that they can be resilient. Also resilient for climate change. This is a photo in Acapulco, and in Acapulco, it was not a hurricane zone, and now we got 3 hurricanes in just the last 2 years, so we need to rethink about the construction techniques. Then, well, this is what News Story said, that they are saving the world. Again, the Americans saving the Mexicans, we hate this. So this is this is the most colonialistic part. This is the solution that the European and the American world are sending to us. Machines for 3D printing. And this is very racist. They put colored people, the happy family, in the 3D printing house. So they came from this using natural materials, like that, from that. Now they are happy. So this is very racist. This is super violent for our society because 3D printing is not gonna solve anything. And this is the solution that they are sending to us. So the current status of housing in Mexico works like this. First, they select the site, they delimitate it, they self-produce with natural materials or local materials, and after this, they did an illegal appropriation, and then they got legal, and then they started to put money on site. So the house started to grow up because depending the family cells. So if your husband, you get married and then you have a son, then your house started to expand. So we have to be able to start to do construction in housing to be able to expand, to be very easy to assemble and disassemble. So I think this is a little bit like maybe a solution, doing like a self-building but prefabricated system that you can be able to expand. So the European book said that in 2057, 2.7 million jobs are going to be replaced by robots. But in Mexico, more than the 60% of the population lives in a really big poverty. So we have a lot of inequality, and more than the 60% of the population live in self-built houses. So why does labor in Mexico are so cheap? First of all, educational lack. Nobody has education. And the second one, we have a lot of big urgency to generate money. So Mexico is a manufacturing country because more than 6.1 million people are engaged to labor force, but they are working extremely a lot of hours in the worst secure condition. They don't have access to a medical insurance. So this is the reality. So this is pictures now in Mexico. If you can get more, I'm very happy. So this is pictures that I got from internet, and also this is an extruder from a 3D printer. Then you need 2 people to put the extruder. So where is the optimization? So in Mexican companies, more than the 60% make use digital tools, and the 93% are using analog tools. This means there is no innovation in our country. And the construction tech sector represents the 4th largest economic sector. But robotic construction is not purely craft. It's political, cultural, social, and economical. So all the builders in the constructions are classified by the government by trabajadores artesanales. They are craftsmen. So if you want to replace the builders, you are replacing your cultural heritage. But the bad problem is they do not have a good salary. They do not have good crecimiento. They are not growing up. They have not developing. And also, it's not equality here. 90% are men and just a little few women in construction. So I was also part of the CEMEX committee 2 years ago, and they also published their new 3D printing in Mexico, and they were expecting very, very good comments. And this is the reaction of the people. The workers, disemployment, they're going to remove my work. No. The answer of the people is no. The people are afraid. The people don't want technology. So the question is, can the revolution still made by a printer cost more than $25,000? Automation do not distinguish between manufacturing or even economics. They want to lead on a point on horizon that is the obsolescence of the workflow. So what's the role of robots in architecture? The robots need to be able to make decisions automatically beyond the human capacity. And I want to close with this image that this is an artist called Stellar, and he said, there is no more human thing than technology, because technology wants to recreate the human body, and they don't want to replace the human species. They want to evolve. So this is an exercise that I did with my students, and I asked them, you have to do something totally digital and then something totally analog. And after this, tell me which one of these methodologies are more difficult. And you know what's the answer? This one, making and working by hand. Why? because they do not have idea how to work with their bodies. They never had a connection with the material. And, well, 3D printing was also difficult because, well, the communication with the machine. So as Mario Carpo said, technology should not be replaced human contact. There cannot be community without physical proximity. So as we can see, there is a lot of good advantages, new materiality, new shapes with digital fabrication, but also working with our hands makes us more human, more intuitive, and more conscious about which materials and why we are working with. So it's never clear where the humans start and ends. Thank you so much. 39, eh?
Thanks, Dinorah. It's a lot to unpack there. So there should be no shortage of questions, I assume. Would anyone like to start? Carla? Yep. Go ahead.
Thank you, Dinorah. It has been a fast ride. I was checking on how many slides you had us through, and it was close to 300. So,
it was 267.
Okay, 267. Wow. I think I already told you there is a lot of your work is strong, and I mean the way that we present it also makes us excited to find the final product. Right? It was funny because not funny. It was interesting because you show a lot of the process, and then very quickly you went to the product and said that's not important. Let's talk about the process, and then you go to the product, and then you keep jumping. And then the last question was about what is the role of technology if we understand that we want to keep our intuition, we want to be able to still leverage our human capabilities. And with the housing crisis, I'm still not sure if you have an answer about robots being the answer to the housing crisis, because we have the celebration of digital fabrication and computational design, but then we have a very hard question about will these help us build better or have access to affordable housing. I just want to pick your brain and see if you have a sense or an idea. Maybe this is about the material, maybe this is about the method, maybe this is about both. I'm curious.
Well, for me, like 3D printing, I think one of the, as you mentioned, like 20 years ago, like we just want considering like robots in construction and that's all. You know, like, yeah, the machine in the construction. Okay, but then we realized we need an application and we need to solve something. Why you're using like robotics instead of the hand or craftsman, no? But the thing is, the housing crisis is not the same everywhere. Maybe in Canada or US or like Europe, as I said, I land in Washington and I look house. So here, how do you get a house is by a company and then you get a credit or like an hipoteca and then you got a house. You don't build it. But in Mexico or Latin America, and I was talking with the guy from Colombia, and we share these thoughts, no? Because in Latin America, most of the people have informal jobs. They don't even are registered in any data. They don't have any credit. They have cash everywhere, no? So they are just surviving with cash. So of course, they don't get houses by a credit. They get houses because they got, 15,000 pesos, and then they say, I'm going to build my new wall. And the next month, I'm going to build the next wall. And this is how the majority of the housing works. There is another 30% that is us, no? The privileged Mexicans that, of course, we call a company, we call an architect, and we build houses. But that's why also architects do not have too much job in Mexico, because there is no money, there is no population, and nobody, it's not the majority. So I am not agree about, for example, News Story or these, American companies that they say oh yeah, we 3D print some houses and then we solve their life from a family. Of course, they got like a place to stay, but sometimes they don't feel comfortable. It's not part of their culture. They don't feel identified with this construction system. And the most important, they are not building community. So you cannot like print like the next wall. You cannot print the room for your child. You cannot do it because you don't have access to these machines, and you cannot be able also for the knowledge of 3D printing. That's why for me 3D printing is not matching with housing crisis. But in the other hand, I think it matches with other things. They maybe it's not housing crisis the problem that we need to solve. Maybe it's just about new materials, it's just about new aesthetics, or new geometrical freedom, or natural disasters. That for me, this is something that I really want to do in the PhD, because natural disasters are, and you know you're the master in this, but they are a different perspective and land, because when a hurricane came, or like an earthquake came, and then you lost your house, the next day you need a place to stay. Doesn't matter if you like it, if you can pay it or not. And then in housing crisis, it's absolutely different. The priorities are others. So for me, that's why we really need to rethink about what we are going to do. A lot of people told me when I talked 3D printing in Mexico, everybody told me, Ronald Rael. No, come on, Ronald is my friend, but he's absolutely outside. First, because most of Mexico are earthquake zones, and the earth don't have the best efficiency for earthquakes. And the second is, yes, you got the earth and it's okay, but nobody wants to live in a cave. That's the reality. The people really wants to live in concrete walls or mortar walls, or these materials that they are used to. It's very, very difficult to just change the mindset, no, in one day to another. So I really want to see what's the real impact, and if there is no impact, why there is no impact. And for me, this is also an answer.
Oh,
Can
yeah,
Sure. Hi, thank you for an incredibly rich presentation. I'm just wondering, in terms of kind of follow up with Carla's question about the kind of a bigger proposal, the sort of a series of experiments and bigger proposal. There's this kind of assumption of a centralized application, or like you assuming that the assumption being like 3D printing solves all because it's kind of adaptive system and it's kind of limited range space that it operates, right? So that it kind of comes to the issue of scalability and repetition across the various different cultural landscape, which of course now works, right? And we've seen it and historically happen through like industrial era, industrial style, through appropriation of industrialization through a totalitarian system. So there's a kind of a modes of a single invention being reproduced across any cultural landscape, produces some different form of totality that we resistant to, right? And then there's kind of a cultural resistance to those moments. And so I'm just wondering, and that's natural, and I think that happens all across the world. So some of the issues you're bringing up are specific to kind of the policy and economy of the region and generally, and then kind of the global south. What are there are other ways of thinking about kind of distributing these models within a kind of a communal design, or different ways of reusing materials across different scales. Do you have any other ways of thinking of the kind of a bottom-up, top-down economical model, how these systems can be used to empower? And I'm just going to give you one example, just because I've been thinking about this a lot lately. We're doing some industrial collaboration as well when it comes to prefabrication and construction in the industry. And usually when one thinks about construction and automation and repetition, right, especially in terms of the robotics fabrication, it's just sort of an adaptability within the form itself. But to me, there is a kind of a coordination organizational model, how things are being done. So there's one model we just, with my work partner, we started working with the company, where their model is essentially the opposite of automation. And it's essentially building a building. It's in a shed, and then slicing it apart, using resource of the local craft, and then kind of redistributing it to the site, right? So in some way it shifts away from role of machine to role of design thinking, right? So there's kind of a model of knowledge building that engages the technological domain, but changes the role of that technology in a kind of a singular model that we're tend to think about it. So I'm just wondering that there's a, the narrative you presented is incredibly strong. It's a kind of a critique we are familiar with, but I'm wondering how is the way to what's next, right? How do you think about the next, and in some way you're the one who's bringing the problem to the forefront, and then you realize maybe, well, this is not the way, but I don't think that it's binary condition. So what are the other ways you were thinking about?
Yeah, it was a very good question because actually now it's like full of problems and not solutions. But first, that's why I want to study a PhD, because I want to carve time to do it and to think about and to write about it, and also to explore new ways to build. But what you mentioned is super important. The other day I was in a lecture of Jose Santibáñez. This is an architect in Oaxaca, and he works with all the workers are like craftsmen, clay craftsmen, and they don't use any industrial material like interceramic, nova ceramic, not anything. They create everything by site, and they create it so all the pieces in the construction are absolutely unique but different. So this is another way to think about it. Why everything has to be fast? Why everything has to be massive? What everything has, the money, but maybe now the money should be in a different direction. Maybe we have first to support the craftsmen because they are disappearing, and then for supporting them and to impact them, I think we should also create community. And to create community, we have to create tools that there could be really, really accessible for them. Like, for example, the little project that I did with Tecnológico de Monterrey, that is the furniture, for me was the first time I only used this Ender 3D printer that is less than 2,000 pesos. That is nothing, it's less than, $100. And for me, it was impressive, the output. The output was a real a modular system that maybe in the lower communities we can use it and we can replay it, like we can impact, because technology, we cannot stop it. That's something that the digital revolution, we are not gonna stop it. AI, we are not gonna stop it. So we need to understand it, and maybe to understand if it's useful or not useful. But yes, like in terms of a model of construction, I also think we should radically change it. Like maybe using the local craft or unique materials that you have there. But the most important part is to understand the context, where you are based. And after this, what the people do in this zone, which materials you have able there, and after this, you can take decisions for innovation. And not just following Instagram or trends.
I was, as you were speaking, I was thinking about other modes of inhabiting space, and I think that probably creating the technology of the breadth that you showed us maybe would be interesting, like creating borders. And this is a conversation that we're having about developing these climate resilient, engineered oyster reefs that will have a very particular meaning and solving a particular problem that is not as big as the housing, affordable housing, but it is contributing to an interesting architectural design project. So, thinking about not in the scale of a house, but maybe thinking about these borders or these specific architectural objects that can contribute to a solution. So that's more or less what I was thinking when you were speaking, that the method becomes also important because the geometry, for example, in this case of the oyster reefs, these needs to be efficient, but also needs to comply with the materials, and all of these things are so complex and also could create beautiful outputs that do need this ability to not do just square.
Yes. Yes. And talking about resilience, we were talking a lot about this word, is also try to adapt, where you are and what the people are doing and how the people live there. So maybe you don't need to print the whole house. Maybe you only need to print, I don't know, some special piece, some special wall, some special border, as you mentioned. But at the end, you also need to understand what is happening there. If maybe also, it's maybe not only a house. Maybe you can also create another kind of spaces as we're going to create in Florida. We are going to do like a, how to say this, oyster reef, no? But there, the function is absolutely different. And then you have to be able to understand the biology of an oyster reef, and then the chemistry of the oyster, combine it with the binders, and then you need to understand the design and the architectural design for doing this wall. So at the end, it's a lot of like things combined, but depends too much of where you are. And this is something that sometimes I don't saw it clearly in the digital fabrication world, because I don't know, I saw people like, I'm focusing on air construction, for example, or I don't know, wood, or eggshell. But it's not about this. It's not about just being like mastering earth, because not all the earths in the world works for construction. Not all the eggshell, not all the places have eggshell available for you. Maybe it's more better to start to understand, no, which ways you have or which materials you have able there, and started to find the better solution there. Because otherwise, all the resources are going to be very expensive. The handcraftsman is going to be super expensive, or you're going to find it. The same as RAM air, we don't have it. Well, we have some, but it's very expensive. So at the end, you will finish it with a concrete thing, no? And also, the concrete is not the enemy. So this is a very large narrative that we have in data fabrication. Concrete, we want to don't use concrete. No, because concrete sometimes have a very good strength for earthquakes, for example. If I were in Mexico City, I'm never gonna build with earth. Like, I'm gonna die there. So it's also another kind of layers you have to take in consideration when you're selecting materials. And you're selecting also methodologies to build or to work with. There. We have a question, eso.
Gracias por tu presentación.
Ay, gracias que habla español.
Yeah, my question is about the food waste projects that you've done, and I wanted to know, where do you see the most promising applications for construction materials that come from food waste? And are you interested in making food waste construction materials more durable, like for example, a load-bearing wall? Or are you interested in the biodegradable construction materials and the applications of materials that not decompose easily in soil and water? I'm just curious to know what you think the development of the food waste construction material should be.
Yeah, I think there is a very big opportunity in food waste, more than plastic waste or other waste, because the organic waste, first of all, nobody uses it. It goes directly to the garbage. There is tons of volumes, in I think all over the world. And then also they are very easy to combine with other binders, like limestone, for example. It's so easy. Like, you just need to transform it in a dust, and that's all. So, and sanitize it, of course. But every single food waste have different chemistry composites. For example, the eggshell is carbonic calcium. So carbonic calcium is almost the same as limestone. So then you can link them. But for example, the wood is like cellulosa. It's absolutely different. It's another world. The drying takes more time. The corn is almidon. I don't know how, starch in English. So starch is not really easy. So depending also the chemistry of each material is how do you decide which material to combine with other binders. And this is how you select the kind of binders. And then the third part is the application. Depending what do you want. If you just want to do, I don't know, like a lattice, a decoration in the wall, and I think this is a very good opportunity, and there is a very big market, for example, in hospitality, for hotels, interior design, and this is the most rich market, so I think we should be there. So in this case, for example, I think there is a very huge opportunity, because you don't need to think about or stress about the compression strength, the tension strength, and all of these physical properties. But if you want to do something outside your house, then the problems are bigger. You have to be worried about humidity. You have to be worried about also the life, no, all the los hongos, fungi, and things. But maybe you want to do, I don't know, a garden, and then you want to grow up some plants. Then this is perfect. Starch are perfect for this, for example. So depending, right now I'm working with coffee, with a coffee shop next in the same factory that I have my workshop. And right now we are doing like a green wall for outside. And right now the binders that we are using, they are absolutely different than the binders that I use in wasp, for example, with the corn. So depending what is the use of these, which chemical composition you have, or also maybe what do you want with this material? If you are able, or if you are agree that this material are going to decompose in the next 10 years, and you agree with that, this is perfect. This is super regenerative, no architecture. But if you want something super permanent, then you need to use another kind of things. For example, oyster shell, that's super permanent because carbonate calcium, eggshell, so lobster shell, that are chitin with chitin with carbonate calcium. So depending what do you want.
Thank you.
My question's about impact. It's a big question. Because there's many ETH alumni here, and I'm also a recovering ETH alumni. I think I'm the first one to confess that ETH teach us to find solutions really, really well, and then we find a global problem and then throw the solution at it until it fits a certain question. And I think what we all need to figure out is how these solutions that we're so good at making, how do we make that jump to address the bigger problem that we always use to justify our work? And I think that missing gap is really the scalability, not just in terms of size, but what enables that scale jump, which is, I think, ultimately, sadly, in this day and age, is economy.
Yeah.
And it's not a question of whether something is cheap or expensive, or who needs it. It's actually who can afford it. Mm-hmm. So my question is, maybe you'll figure this out in your PhD, but I think whenever, again, myself included, whenever I see a picture of a robot, I think comparing architecture as a discipline to something like Ford's assembly line is that those industries tend to hyper-specifically allocate all their resources to perfect the process to create one perfect thing. One piece of a car is just going to be the same on every single car, whereas no two buildings will ever be the same. Which is kind of why small pieces of architecture is always standardized, like this railing, like a CMU block. There's a reason why it's universally used. So I guess my kind of question or thought for you is, like, I think we understand the solution and the problem, but then like in between is kind of still unclear to me. So like, what is your thought as you start your PhD, which is going to be a pretty, I think, rewarding journey? What is your kind of outlook on that? Because I think you painted like a pretty, like a very broad and agnostic kind of view of various problems. But what is like your, outlook as you enter this new?
Yeah, that's gonna be tough. No, first of all, it's gonna be tough, Carla. You have a lot of work, but we have a lot of work. But the thing is, I think first of all, yes. Like I was talking with the coordinator, the career coordinator in my university, and he told me now is absolutely crazy and expensive. We need to buy a lot of infrastructure in terms of technology, like robots, 3D printers, blah, blah, blah. And 20 years later, we just need some desk, and that's all. We did our profession. So the profession is evolving. I think everything is evolving. It's not going to stop. But other thing that I believe is we should create like a real cooperation with machines. I don't know if it's cooperation or collaboration, because cooperation happens in the same time and collaboration one after the another. But at the end, we need to really create like a system that we can be able to use machines sometimes, but then use hands other times. Otherwise, we're going to lose our human condition. That is something real. We're going to start to be machines. I think the project from, I don't remember her name, but Dina, it's very interesting because you are trying also to merge these layers, try to communicate in some point. Of course, it's the start of something. So I think this is one of the good things. Maybe it's not applied for construction because this is more for teaching and training, but we need to do something similar or maybe something. And other thing that it's real, it's everybody have a cell phone. Everybody. Also in communities, in rural communities, in the most poorest neighborhood, everybody have cell phone. Everybody have social media. Maybe it's there where we can impact a bit. No, maybe it's there, or maybe we can create, I don't know, like construction. I'm sure about process like hologram. I don't think so, but maybe something that we can be able to read and to use, because coding is so hard. Using a robot is so complicated, and nobody have access to this education. We are just 1%, very little percentage of this population. So maybe we need to, I don't know, started to think about something in between. I don't know what's the answer, actually. I don't have idea, but I have all the motivation to look for it. And maybe if the answer is not no, that's also another a very interesting answer, because maybe it's just another methodology to build. That I think this is the more acceptable answer, because maybe 3D printing is just another methodology to do the things. Maybe you want to use 3D printing here and then the hand here, and it's absolutely acceptable. I don't know why we need to compete. Like, that's something that, why? What's the necessity to compete?
Yeah, the last question maybe.
I'll just add maybe one quick thought, because during this question about scalability, I was sort of fascinated by the slide where we had basically kind of like the social media responses to right? We're like, no, we're going to take our job. But at the same time, like, these are also people who learn how to use cell phones, right, in a very short period of time. And so I think like there's a kind of part of this problem that's about how can you empower them, what kinds of tools you can deploy. Obviously, we're talking about, programming 6-axis robots has a certain curve, but then maybe it's the ender, maybe it's something. And as long as we're able to show them, like what, how they can be empowered by something, then they'll adopt it, right? Wildfire, I think. And then, the revolution begins.
Exactly. I think the people started to be angry and frustrated because they are absolutely all of these are bad comments. The only good comment maybe is this one, like furniture and public space. That's the only one. The others are just hate, no? And they are frustrated because they don't know how to do it. And that's the problem. So, and also in the video, they do not help because they are not showing humans in the video. I told them, show humans, guys. If you just show the machine and the protagonist is the machine, it's a very big mistake, because then they feel threat. So we need to create, as you mentioned, less empower of these people, and also understand that these people, most of them, get educated in universities. And universities play a very important role for this. If in the architectural schools in Mexico or Latin America, they do not start to innovate their programs, also to exchange, maybe with Europeans, Americans, or Asiatics, it could be amazing. Because they can understand, okay, there are more people using it, maybe I can learn it. And I think this is happening in AI, more than in digital fabrication. But it's also because the machines are so expensive. Here there is a comment that they say, 30 million to build this. So the people are saying, I don't have 30 million. And if I have it, maybe I'm gonna buy a house, not a machine. So that's the problem with this. We are absolutely disconnected with humanity. And that's, I think, we should do. We have to connect more with humans, do things human-centered, not machine-centered, and not capitalism-centered. And all these companies, and I really love WASP people and 3D Prote and Cobot, and they are my friends, but at the end, they are not thinking about it. They are thinking to sell more and more. And the formula for selling machines is the same like Henry Ford. That's the same. But the formula to building houses are not the same like Henry Ford. And that's the disconnection that we are having now. I think in Mexico we tried tons of years. There is an institute called Infonavit, that is the Institute of Housing in Mexico. They are like since the 19s and the 70s working to doing modular houses, now 3D printing houses, now they are trying to look at an answer, but they already got that the answer are not the houses, are the economical problem. It's an economical and a political problem. So it's out of our hands too. So why we want to solve the world? That's all the thing, no? Like maybe we should use 3D printing just to get, I don't know, freedom in terms of geometry, freedom in terms of materiality, maybe circularity. I think this is working perfectly. Like now it's a reality. But like changing the house and change the condition of humans, and that's why the people feel threat. They are absolutely disconnected, but as you said, they are using social media. This means they have Wi-Fi and they have technology. So maybe we should do something here in this scale to try to get them. Well, this is my answer, I think. So. I don't know if someone else, and if it's not, thank you so much for everybody.